Mark this up, and this might be a good thing to do on your notes too, and then you could write down this example on your gold sheet. So we know, let's say, hypothetically, that angle 1 is 140 degrees. So is angle 3. And angle 2 is 40 degrees. So we know that angle 1 and 2 are supplementary. We also know that angles 3 and 2 are supplementary because they add to 180. And so we can say that 1 is congruent to 3. And that's what I'm doing when I do that marking like that, the arc. I'm saying they are congruent. That's how we mark congruent angles, with the little arc. So since they're both supplementary to angle 2, they are congruent to each other. We can say that angle 1 is congruent to angle 3. Let's say that this is 30 degrees, so is angle 6, and angle 5 is 60 degrees. So angle 4 is angle 4 is complementary to angle 5, so is angle 6. And so what we say is that 4, I'll do 2 lines, it's a different problem. 4 is congruent to 6 because they're complementary to the same angle. Because they're both complementary to angle 5, they're congruent to each other. Now most of the time you will not actually have the angle measures, you'll just be told 4 is complementary to 5, 6 is complementary to 5, so then you would conclude 4 is congruent to 6. Angle 4 is congruent to angle 6. So we are given that angle 1 and 2 are complementary and angle 1 and 3 are complementary. Here's the thing. This is actually a proof of congruent complements theorem. So we are not going to use the theorem on this problem. But let's think about it. So 1 and 2 are complementary and 1 and 3 are complementary. Prove that angle 2 is congruent to angle 3. Why does that make sense? And angle 1 and 3 are complementary. By the definition of blank angles, we can say that measure of angle 1 plus measure of angle 2 equals 90. So think to yourself, why are we allowed to say that measure of angle 1 plus measure of angle 2 equals 90? By the definition of what, Hayden? Complementary angles. Yeah, so the definition says they add to 90 degrees. So I'm basically just saying, I'm saying my reason before I say my statement. Because in a sentence you can say that. By this, we are allowed to say 1 plus 2 is 90. We could also say something else is equal to 90. What's another equation that we could write? Angle 1 plus angle 3. Yep, measure of angle 1 plus measure of angle 2. No, measure of angle 3, that's what you said, is equal to 90. Because they're also complementary. And then, this is a property. By some kind of property, you are allowed to say that measure of angle 1 plus measure of angle 2 equals measure of angle 1 plus measure of angle 3. Right. Since they're both equal to 90, they're equal to each other. So you can take those two separate statements and combine them into one with transitive, since they're both equal to 90. Okay? And then by subtraction property of equality, something. So think about what could you subtract from both sides of the equation that you just had. And so if I take away measure of angle 1 from both sides, what are we left with? So take it away. So all that's remaining is what?
Measure of angle 2 equals measure of angle 3.
And then so we're allowed to say angle 2 is congruent to angle 3 by the definition of what, guys? What is it? Congruent. Since they are equal, they are congruent. So first one, we are given that angle 1 is congruent to angle 2. Your picture is clearly not to scale, but you should go ahead and mark that in your diagram. So 1 is congruent to 2. We mark that by putting the same type of arc on each one. It's given, so let's write that also in our proof. Okay. What Abby said, we're going to use vertical angles. So 2 is congruent to 3 because of vertical angles. Vertical angles congruence theorem. We talked about that yesterday. It says that if they are vertical angles, they are congruent. So we now know that 2 is congruent to 3. You can mark that in your diagram. So we give 3 the same marking as we gave 2 because they're congruent. So now we say that 1 is congruent to 3. Why are we allowed to say that 1 is congruent to 3 now? Look at your statements. Right. 1's congruent to 2, 2 congruent to 3, so skip the middle, transitive. Because they have angle 2 in common. And there's a typo where it says angle 1 and CBE are complementary. That is false. It should say CBD. On both of those. Angle 1 and CBD are complementary. Angle 2 and CBD are complementary. Let's mark those right angles in our diagram as best as we can. ABD is this one. And then CBE overlaps that. So you actually get 2 right angles. So it's kind of hard to draw. Do your best. And then we were told that we had right angles, and so we said that angle 1 and CBD are complementary and angle 2 and CBD are complementary. Brooke, why'd you say that? Right. They add up to 90. They're a right angle. And so look at these two statements. Angle 1 and CBD are complementary. I'll do this. Angle 2 and CBD are complementary. So what can we conclude? Right. They are both complementary to CBD, and so they are congruent to each other. So where it says PSR, PSR is really just angle 2, and that's going to make it a lot more complicated. So let's just change it to angle 2. So when it says PSR, really, we just mean angle 2. QRS and angle 2 are supplementary. Prove that angle 1 and angle 2 are congruent. Your thoughts, why does it make sense to you? Reese, what do you think? Why does it? So 1 and QRS are a linear pair. And so then we say 1 and QRS are supplementary. Alex, why are we allowed to say that?
Because they are a linear pair, and according to the linear pair,
We talked about the linear pair postulate yesterday. Since it is a linear pair, they are supplementary. So right now we've said QRS and 2 are supplementary. 1 and QRS are supplementary. Look at what you have. Why are we allowed to say that angle 1 is congruent to angle 2? Why is it congruent supplements?
Because the two angles
Right. They are supplementary to the same thing. What are they both supplementary to, Reese?
QRS.
Yeah. Since they're both supplementary to QRS, they are congruent to each other.